Welcome, Anders Hejlsberg, truly a hero of ours for over 20 years.
We were all kind of like walking around like with these scared looks on our faces going, oh my God, is programming languages, are they dead?
Old-time NBA players who look at the modern game and they say, this game is soft. Programmers, we knew the cost of every kilobyte.
Typescript was one of the first open source from the get-go projects at Microsoft.
You're known from everything from Pascal, Delphi, being the architect behind C#, the cornerstone of everything with .NET. For the last 10 years, leading the charge on Typescript.
Everybody wanted the ease of use of Visual Basic's rapid application development and the power and expressiveness that C+ had. And we could give them one or the other, but like trying to marry the two was hell on wheels.
Mother of God, why would you do that to yourself?
This is my calling, is writing code.
So Anders, it's such a pleasure. Thank you so much for coming on our show. Ladies and gentlemen, we have an absolute treat for you here today. Somebody who's truly been a hero of ours for over 20 years.
Yeah.
And in some ways, I think his work was the reason or one of the entryways for us into the world of computers. You know, I've spent thousands of hours writing code in the language he's built. It's kind of hard to sort of sum up the amount of impact he's had on our industry. So love to welcome Anders Hejlsberg. Let me do a quick introduction. So Anders needs no introduction, as they say, but, you know, among other things, you know, I would say you're known from everything from Pascal and your work in Delphi in the 90s to being the lead designer architect behind C#, kind of the cornerstone of everything with .NET. And for the last, and then a lot of things on top of C#, we're going to get into Link, we're going to get into a lot of fun stuff on top of that. But then for the last 10 years, you know, leading the charge on TypeScript. Yep. But so, you know, Anders is an icon in the world of programming languages and how to think about how programs and software are written. And it's very hard to think of more people who had impact on how we build the software we use every single day. So Anders, it's such a pleasure. Thank you so much for coming on our show.
Well, you're so welcome, and thanks for all the kind words. This will be fun. I'm excited to be here.
Okay, so we're going to get into all of your amazing work, but maybe I want to go back to the Anders origin story. Talk to us a little bit about how you and your brother actually got into computers, got into coding, and maybe what sparked the interest in the idea of programming languages.
Sure. So I grew up in just north of Copenhagen in Denmark. Sort of a very nice middle class, unremarkable, but I was fortunate enough to attend a high school that was one of the first in Denmark to give the students access to a computer. And this is way before micros. In fact, the first computer the school had all the only I/O device was a teletype and a paper punch reader and writer. But then I think the one that we had access to when I finally made it into high school, and we're talking about like the mid 70s here, was an HP 2100 with 32K of ferrite core memory. And you could literally see ferrite cores. I mean, it was quite remarkable if you opened it up. And boy, trust me, we did everything to that computer. And it had a 14-inch 1 megabyte hard drive, which was just state of the art. And I mean, and we kind of joked, you know, or I've joked before that for the first 2 weeks, the teachers were trying to teach us how this computer works. And then for the remaining time, we taught them how it worked, you know, because we just spent all the time we could on this darn computer and figured everything out, you know, like how to program it, machine code. And it came with, it was an HP 2100. It came with, I think there was an implementation of a base, which was sort of, and then there was Algol, HP Algol, which was Hewlett Packard's variant of I don't know, it's lost in history what how that differed from regular Algol. Although one thing I do remember is it did not support recursion. So you had to be careful to not have your functions call themselves, because then you never saw that program again, you know. Because the call instruction would store the return address in the first word of the function you were calling. So that only worked for one call. Anyway, but you know, we sort of got to learn from the very bottom up, you know, how computers worked and how languages were built on top of computers, and how you write programs in those languages, and what happens when they get compiled and turned into machine code, and et cetera, et cetera. We learned what bootloaders were, and how you could plant your own bootloaders on the hard drive, and perhaps modify the attendance records when the attendance record was inserted by the who kept school attendance, and so forth. So we also learned how to write viruses. I mean, it's like we learned it all, right?
Yeah.
I mean, but it was fantastic, and that was kind of what got myself and my brother interested in programming. It probably helped that my dad was at the time, and has for his whole life really worked for Motorola, and he ran their distributorship in Denmark, and so he was an engineer by trade, and and my brother and I are kind of that same ilk, So yeah.
Do you remember what got you interested in the idea of building your own or programming language or designing your own language?
Sure. When I started at DTU, the Danish Technical University, in '79, and met up with some folks who had already started a small company in Copenhagen, and eventually ended up becoming a partner in that company. And we had the first retail computer store in Copenhagen, where you could walk in and buy, which at the time, an 8-bit micro, right? The kit computers of the time, the Sinclair ZX81s and Commodores and whatever. And but before that, even, there was like these. We sold this British kit computer that was based on a Z80. You had to like put it all together yourself, and I wrote an awful lot of software for that. So I got and pretty quickly got good at machine code programming, because when you only have 64K of memory to do good with, you got to write in machine code if you want to really squeeze features in there. And I think I was interested in, I mean, there were obviously programming languages available, there, but it was basic, right? Microsoft's ROM basic, and it was slow and sort of had all sorts of limitations. And I had been taught Algol, and I was sort of interested in, it'd be fun to like try to write an Algol compiler. I was stupid. I didn't know, I mean, and then my partner was saying, there's this new thing called Pascal, you ought to check that out. That's like, it's supposed to be better than Algol, whatever. I'm like, oh, really? Okay. So taught myself something about Pascal, and it turns out that, one of the traits of Niklaus Wirth, who worked with Algol and then invented Pascal and Modular and Oberon and a sort of whole lineage of languages, is that he kept making his languages simpler. So, so Pascal was actually in many ways a simplified, cleaned up version of Algol that was great for as an instructional language also, but it was quite easy to implement because of the rules of the language. You could do it sort of there were no forward declarations and whatever. You could do it a one pass compiler could do it all. And so I got curious about that, and of course I didn't know anything about compilers, and so I had to sort of teach myself that by experimenting, right? But gradually got a subset of Pascal implemented. That you could rip out the Microsoft ROM basic and then insert our ROM instead, and when you powered up your machine, you were sitting in this little sort of on-screen editor. Actually, it was sort of like an IDE, but when you typed run, it would actually compile it and then run the machine code, and of course it would run rings around the basic and so.
This brings up, there's some fun memories, because one of my first kind of non-trivial projects I ever wrote was a Visual Basic compiler, right? Where I did the whole 9 yards, right? Like, built a Lexer parser and then tried to spit out even VB that tried to spit out the CLR. I want to go back to actually that time, because if you think about that era, late 80s, 90s, right? You're dealing with the fundamentals, right? You're dealing with the registers, you're dealing with the opcodes. And there's an analogy here. I watch a lot of the NBA, and modern NBA players, old-time NBA players who look at the modern game and they say, this game is soft, right? Because back in the day, we really had to duke it out. And there's a bit of an analogy here with programmers.
Soldering iron versus.
Well, yeah, a little bit like, hey, we knew the cost of every kilobyte and we had to go up with this. So,
Absolutely.
do you think there is something fundamentally better about being so close to metal that gives the programmers from that era skills and understanding that modern programmers don't have?
Yes and no. I think it changes programming in I mean, like in order to be a good programmer, in order to write something like Turbo Pascal at the time, you had to be bang up good at writing machine code, because there was no way you could write in a high level programming language. And so it definitely cut down the field to very few people. But it also forced you to do an awful lot of uninteresting housekeeping and debugging, and a whole bunch of byte fiddling. If I can make this long jump that we have here, I could save a byte by short jumping to this short jump, and then it was literally like that, right? You were just fiddling away, and oh my God, this afternoon I saved 100 bytes, by. And so in that sense, it was a craft, right? But it was also very much capped at what you would ever be able to produce. Because 64K was ridiculously small, and even 640K, even though Bill at one point said whoever needs more than that, right? But
No.
but even that was clearly not enough. I think today I sometimes lament the fact that this enormous capacity that computers have now is basically a bottomless pit, right? And you can build software on top of layers of layers of layers of layers of layers, and no one can see anywhere half to the bottom, right? And so it gets to be this big swamp of spaghetti code and whatever. And there's less craftsmanship, if you will, sometimes. But on the other hand, you get to leverage other people's work way more than you could previously. So
Right.
overall, I think we've clearly moved the industry forward, But yeah, us old guys can pine for the old days,
Back when we knew what, I think there is some, we're going to talk later about things like GitHub Copilot, with very different kinds of code reuse. But I do think there's a little bit of romance in the, for example, I idolize, you and folks like John Carmack. And John Carmack, noodling away and trying to, make sure every instruction and memory access is aligned on some cache line. And the amazing thing is, like, even today, if you look at like AI, at the heart of it, you have matrix multiplication and kind of doing things with floating point numbers. Some of these things really tend to matter. Okay, on the theme of optimization, tell us a story of Turbo Pascal 2 and you discovering hash tables, because it's legendary.
It is a funny story, because so you have to remember here that I am sort of self-taught in the art of writing compilers. Now, I have since discovered and read a lot of the literature, but at the time I was just coding away and doing it the best way I knew how. And so when you create a compiler, one of the things you have to create is symbol tables, well, they're not necessarily tables. They could be linked lists. They could be whatever. But you have to look up names. Like when you're trying to compile a code that tries to assign 1 to X, well, you have to figure out X. Where is X? What memory address have I associated with X? So you have to look it up. You have to look up the declaration of X, right? And in Turbo Pascal 1.0, the first version of Turbo Pascal, all of the variable declarations were just kept on a linked list, because that much I knew, but of course searching linked lists is not particularly efficient when they get large, right?
Right.
And so for really large functions, that would just take an awful long time, right? And then, well, maybe you could first try first going by first letter, and then have 26 linked lists or whatever, and that could help a little bit. But then I remember reading the literature about these things called hash tables, actually in this book by Niklaus Wirth, Algorithms plus Data Structures equals Programs. Great book. And he explains, hash tables, and I go, oh my God, that's amazing. I got to go try this. And I went and implemented it, and boom, the compiler went twice as fast. So, well, there's Turbo Pascal version 2.0, So
Awesome.
there's a good reason to sell upgrades, and
So this actually, I want to get to your time at Boulder and Delphi. And this actually, I'll tell you a story. And I don't think we share this in public. So and you may not like the story, which is Visual Basic 6 is the reason I think both of us, or at least I, have my career, right? Because what happened in the mid 90s was that, my dad back in India, he got me a pirated version of Visual Studio 6 because we couldn't actually afford the real thing. And, I would install this. I'd be like, And for me, the WYSIWYG actually and that whole thing was powerful. Drag and drop and being able to kind of go to subroutines. And then, once I got a little good and I understood, I kind of started running into the limitations of VB6, right? It wasn't actually, oops, and you couldn't actually compile it and blah, 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 right? And then I would look at these code written in Delphi, right? Which you could always tell because you get that little distinctive green check marks and the Delphi UI.
Yes.
And you could do all these native things. For example, in Visual Basic 6, if you want to kind of repaint the windows in ways Windows didn't want you to, you are kind of you're spelunking into Win32 DLL in ways that man didn't intend and God didn't want you to. And then I would look at the Delphi folks, you'd be like, oh my gosh, here they're doing all these amazing fancy stuff. And I was always so jealous, right, of the world of Borland and Delphi. So maybe with that sort of a segue, talk to us maybe about your kind of journey into Borland, Delphi, and maybe paint a picture for maybe those who were not around then on maybe the industry with terms of Borland versus Java and Visual Basic around that time frame.
Sure. Well, so to complete the historical arc, so because of my work with writing these small compilers for Z80s, we ended up in this little company we had in Denmark, we ended up connecting with the people who had founded Borland, and it ended up creating a royalty deal where they would rebrand our compiler and sell it in the US, the US rights. And that was what became Turbo Pascal. Now they put a different editor on it, a different menu system and so forth. And then of course, Turbo Pascal took off and became immensely popular, much more than we had ever anticipated. And that ended up sort of being my main gig. And eventually I joined Borland as a instead of being on a royalty contract, I became a full employee and stayed with Borland until the mid 90s. And so the successor of Turbo Pascal, we did, I think 6 or 7 versions of Turbo Pascal. And then of course at this time now we're in the mid 90s, early mid 90s, and graphical user interfaces are starting to become a thing. And Visual Basic was this very revolutionary product that Microsoft had created that gave you this rapid application development environment where you can drag and drop controls onto forms. And it was actually pretty cool, how easy it was to create graphical UIs. But of course, the language underneath was Basic. And it was interpreted, and it was not a very powerful language. And we felt, hey, maybe there's a there. Maybe this is where we ought to have a real compiler. And also maybe this is where we really ought to have real object-oriented programming with classes that you can inherit from and methods you can override and all of the good stuff that had happened. And so Delphi was sort of an amalgam of all of that. Plus we also built a whole set of controls to allow you to build nice client server apps, because that was how you could get into the enterprise at the time. There were products like Power Builder and so forth, where but the people who had the money were the enterprises, and they wanted client server apps. And so that sort of became our way into more professional programming, if you will. But it was a fun ride. And then, like you talked about, yes, you couldn't repaint the form. And one of the things that we valued a lot in Delphi and its visual class library was, that there were always escape hatches that would allow you to get down to the underlying OS. And so you could obtain the window handle and then the WinProc and then get down there and actually call directly to the OS and do all sorts of good stuff. And people loved that, right? Yeah. Because with VB there was always this glass ceiling and you keep banging your head against it, and and then you were stuck, right? So
with VB it was so hard because but by the way, a lot of the audience watching is like, what are these folks talking about? But in VB, you had often this language of these B strings and and things which didn't look like D words or 32-bit things. And when you passed these things and called, if it didn't work, and you had to change the calling convention around from standard call to CDEC, the whole all sort of thing. If something didn't work, all you got was it just crashed. right? And debugging was a nightmare. It was painful. And that was there. The other narrative which played out in this era, I would say, which dominated the industry was the rise, excitement, and then the fall of Java. So maybe talk to us a little bit about, okay, let me ask you this. What do you think Java did right? And what do you think eventually happened?
Well, so now we're in the mid '90s, and I'm at Borland actually, and I remember, so there was this, all of a sudden there was this thing called Java, and well, first there was this thing called the internet, which of course was huge, right?
Yeah.
And then there was this thing called Java that, the internet taught everybody that cross-platform all of a sudden is going to become incredibly important, right? I mean, here we are, we're all like on these languages that are closely affinitized with this, that, or the other OS and desktop and what have you. And so everyone was sort of going, what's the language? What's programming going to be like in this new internet dominated world, right?
Yeah.
And Sun was brilliant at positioning Java as this is the language that is basically gonna rule them all on the internet.
Yep.
And they had applets, and they had the little guy that looked like a penguin or whatever.
The coffee, the steaming,
the steaming
coffee and water. Right ones run anywhere.
And there was even, the industry totally went bonkers. I mean, there was the Java fund. It was like $100 million fund whose sole purpose was to invest in companies that wrote Java programs. It didn't matter what the programs did. As long as they were written in Java, you could obtain funding.
Yeah.
And we were sort of, we were all kind of like walking around like with like these scared looks on our faces going, oh my God, is programming languages, are they dead? Is that the end of it? Are we all like done here? And honestly, there was a feeling for a while that was going to be the case. And this was also like at the time where, Borland was starting to not do as well competitively with Microsoft but Delphi had done well and had irritated Bill enough that particularly because we were stepping on BASIC, which was his child, right? And then so ultimately I ended up then joining Microsoft at that juncture, and ostensibly to work on Microsoft's Java development tools, and ended up working on Visual J++. The first version of it that I worked on and shipped was Visual J++ 6.0. Remember?
Wow.
And this is now we're back in I think '97. I joined in '96, and then so this must have been in '97. I think or maybe '98. We'd actually built a really nice product. The first product we built was, that was almost completely done when I got to Microsoft, was VJ++ 1.1, which was just take Visual C++, take out the C compiler, stick in a Java compiler instead, and call it a product.
Right.
But of course, that wasn't quite it. But Visual J++ 6.0 had, it had visual programming and like a whole bunch of stuff. And of course, because it ran on Windows, it also had features that made it easier to write Windows programs. Now that turned out to be a major problem in retrospect, because by Sun's reading of the contract, we were not permitted to do that. I will to this day swear that the contract said we were permitted to do it, but it doesn't matter.
Yep.
But the product literally ended up being enjoined by a judge in San Jose, and who forced us to put up big warning dialogues. When warning, you are about to enable unsanctioned language extensions. Do you wish to proceed? And very quickly we realized, it's not going to work for us to build our future on someone else's on technology license from a competitor, right? We gotta build our own thing. And that's such that we can serve our customers, right?
Just to paint the picture for folks, right? Like a couple of stories here. One is, for those who are too young, back in the day, if you ran a Java application on the client side, it was going to look and feel so different. Even with Swing, their modern tools, it didn't feel native Windows. It was slower.
Yeah.
It took a while.
Yeah.
It felt different. And the VJ++ apps, which I'm pretty sure most people here haven't experienced, would actually feel like native Windows. So we have a story. So our first job at Microsoft was in Hyderabad at the India Development Center, which actually, I'm not sure you know this, took over the development of VJ++.
Yeah.
So we used to sit right next.
That's correct. Yes.
and as a result of some of the legal regulatory issues that had fallen out, there was this huge wall where like every meeting had a lawyer. It was a whole thing.
Yeah, I mean, I think when we joined, it was a very different Microsoft than even the late 90s Microsoft, because they'd all been through a ton of legalese and process around what can be shared, what can't. And we were all, in the same building, bunch of cubicles together, but there was this like fine like divide, this line of like, oh, you guys work on VJ++ and we don't. We used to work on Visual Studio. And so it was very, very different. Processes were different. Who we talked to, what was the legal process, like everything was very different and it was just completely divided.
Yeah. You had to be black box there, just like, Yep. I mean, it was a crazy time, quite honestly. But you're right that with, I do remember the original Java with AWT, it very much showed the limitations of cross-platform. And even to today, there's this tension, right, between like frameworks that allow you to write like apps that run everywhere, but they don't have quite the native look and feel. And customers always want like apps that have the native look and feel. And so that tension exists still.
Yeah. It's great because I was just reading a discussion on Hacker News the other day about Electron and Electron apps, right? And this exact thing now comes up, which is, when do you write like, something which renders inside a browser versus something which renders natively versus something on mobile. So this discussion, I think, will never, ever go away.
No, and it's interesting because it's like, in some ways it makes it easier to write the apps because you only got to write them once. But it also makes it harder to write the apps if you want them to be native look and feel, right? I mean, because now you got to be really good at making that framework sing and dance on in native ways, right?
Yep.
So,
Now, this may be, I want to come to this part, which I think is like a very unique moment for Microsoft, which I would say is the design of C# and .NET. So there's a lot of constraints there, which even from my I was just a kid, we're just kids. But one was you had to compete, you had to win the mindshare of the Java developer base, right? There was also this controversy of like, are we moving people away from VB6 into this other world and losing this hobbyist rad development? So there was a lot going on in there. So talk to us maybe about C#, the design process that led into it, and maybe some of the internal discussions.
And also, I think the .NET framework, we ended up working on that and on different parts of the .NET framework itself, is integration with Visual Studio, but also I worked on the CLR. And so this was something that we were deeply passionate about. So how did you think about C# from a concept to actual implementation?
Well, I think one way to look at it, at least, and I think it definitely was front and center in most of our thinking, was that we had at Microsoft at the time two very large constituents of developers. There was the C++ developers, the native code, and then there was the VB6 rad guys, right? And the reality is that everybody wanted the ease of use of Visual Basics rapid application development, and everybody wanted the power and expressiveness that C++ had, right? And we could give them one or the other, but like trying to marry the two was hell on wheels, right? And like you try to write VBX controls or try to write native code or OCXs or whatever they were called, OCX. Many things, right?
ActiveX controls.
ActiveX,
You tried to write COM interfaces and OLE automation and blah, 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 and it was horrible.
iDispatch, iUnknown, oh my God.
I think for college, I ended up writing a DCOM interface. Back when I was in college, one of the projects I did was to write a DCOM interface And I remember
Yeah.
telling that
Oh,
to
yeah.
Sriram when he was in college, and he was like, "Mother of God, why would you do that to yourself?"
It was not easy. Yeah. So there were a bunch of these constituents.
Sure. Also, I think so. We also knew that COM as a runtime, it wasn't really a runtime. It was a more like an ABI, a binary interoperability standard between apps, right? But there wasn't a runtime. There was no framework. There was no shared library. There was nothing that allowed you to abstract the OS, and so you were at this hopelessly low level, right? And so there was a need both for a runtime and frameworks, and there was a need for a language that somehow tried to straddle the fence there and give you both the ease of use and the power and expressiveness, of these other two languages. And that was sort of what was in our minds when we designed .NET and C#. I mean, we kind of knew with C# specifically, we knew from the onset that if we're ever going to appeal to Java users or C users or C++ users, it has to be a language in the curly brace family of languages. It's not going to be based on BASIC. But we still need BASIC because we need a path forward for Visual Basic users and whatever. And plus, there's all these other languages. And really, wouldn't it be cool to build a runtime that could serve all of them, a substrate that all of these could build on, right?
Yep.
And that was so for C#, the vision was sort of like, create this blend of VB and C++, right? And for .NET, it was like build a substrate that allows you to have multiple languages host on a common set of services.
Yeah.
And that's why it's called the CLR, right? The Common Language Runtime.
So here's a fun question for you. I think, I don't know how many years, it must be over 20 years now since C#, or 22 years, since the PDC 98, right, was when .NET was first announced.
PDC 2000 was when it was officially released, yes.
Right.
But we worked on it since before that, obviously, yeah.
So it's over 20 years. Looking back, what is one design decision that you are proud of for how it has withstood the test of time? And what is a design decision that you're like, I would like to maybe have that one back?
So many. I don't know. I mean, it's hard to say. I think we got a lot of things right. I mean, if I had to pick one thing that I thought was pretty cool, it's sort of like we had this unified type system where everything is an object, even though we are actually a much lower level language. And then that meant that from the get-go, we had concepts like boxing and unboxing, built in and understood by the runtime deeply.
Yeah.
And even understand, and then, in 2.0 we got generics, which I think was a wonderful feature. It was implemented by Don Syme and Andrew Kennedy, and Don Syme, who then became the creator of F#. And it sprung out of Microsoft Research, and they did a lot of the implementation work. And our generics implementation is pretty cool and unique in that it's reified generics, meaning that they're understood at runtime. You can instantiate generic types at runtime, where Java's later implementation of generics is based on erasure, and that has some very odd effects at runtime because the generics are gone then. Anyway, I'm like off on a sidetrack here, but it's that those are things that I think we got right. I think the thing we got wrong, perhaps, was to sort of wholesale go with established practices and allow the null in the door,
I was actually had that. I was going to say, is it going to be nullable types is your... Okay, I got that right. Okay.
Yeah. So I always felt like in retrospect, it sure would have been nice to try to exercise nulls a bit more and basically make it possible for you to have non-nullable reference types. That was the thing that was lacking, in C# from the get-go. Now we've done some work now, but this is like 20 years later, right? But back then, if you declared a string, any string could also be null. And there was nothing you could do to save yourself from that. And any object could also be null. And the compiler could not guarantee in any way whatsoever that you had initialized your object to not be null. And that meant that things could blow up in your hands at any point in time. And of course, things do, and Hoare called this who invented null, called this his $1 billion mistake, right? and I don't know, it's probably more like $1 trillion mistake. I mean, when you consider how much money we've all spent on debugging programs because you ask any group of programmers that programming languages that have nulls, what is the most common bug you run into? It's a null pointer exception, right?
That's right.
Now, functional languages have made a lot of progress in that space, and we have two in TypeScript, and now C# even has adopted some of these ideas,
So, I was going to, in the 2000 to 2010 era, right, which is C# 10.20, which had generics, it seems like almost like, and for me as sort of a layman developer, there's like two parallel tracks. There is the static compiled runtime languages, which is CLR, Java, which I think was kind of slow on a downtrend at this time and, wasn't really getting the adoption used to. But then you kind of saw the rise of the dynamic languages. You saw Guido with Python. Guido is now at Microsoft, and Ruby, and then Ruby on Rails, and, which had some concepts like, dynamic types, closures, some sort of like sprinkling of some of the concepts from, more esoteric functional languages.
Stuff,
so when you were kind of at Microsoft, when you're watching these, like what were you observing? How did you kind of read that era of all the open source dynamic language ecosystem?
Well, I mean, dynamic languages was nothing new in a sense at Microsoft, right? Because BASIC ultimately, Visual Basic is a dynamic programming language, and of course we had our Internet Explorer team, and we had an implementation of Java, and so we had plenty of dynamic languages around. And we actually had plenty of need to interact with dynamic programming languages as well. And even I think it was in C# 4.0, we introduced the dynamic keyword and dynamic types and the ability to do late bound calls and so forth. But of course, that doesn't really capture why people were interested in dynamic programming languages, right? I mean, and the thing about dynamic programming languages is they dramatically lower the barrier to entry, right? Because hey, you can just start writing code, see what happens, right? I mean, you don't have to say, oh, x is x is whatever it is I say it is, or I can put anything into my variable here, right? But of course, as programs scale, that can become a little bit problematic, right? Because now there's how do you check that this code is actually going to do what you want it to do when you have given no hints in the code about what kinds of things can I stuff into these data structures and variables of mine, right? And of course I'm sure we'll get to talk about TypeScript, and that's sort of one of the big things there, right? Is precisely that.
I think like every language runtime, at the time I was kind of bounded. For example, Python, had the whole, if duck typing, if it looks like a duck, etc. But Python was really bound, I think, or constrained by the GIL, the interpreter lock, and kind of this one. So I think in some ways, the nirvana was going to be a way to marry the performance and optimization and the JIT of something like the CLR, but with also the expressivity and just kind of the ease of use of something that Ruby or Python brought to board, which brings me to what we want to talk about, which is, I would say the one language is probably dominated in probably just lines of code written or used by all of us over the last 20 years, has to be the one that Brendan Eich invented, which is JavaScript. So maybe talk to us a little bit about the origin of TypeScript through Scriptsha, but maybe before that, JavaScript, like JavaScript apps getting bigger, what you saw, what interested you, and then you being like, okay, I'm going to roll up the sleeves, I'm going to go get back into building things again, and then making TypeScript, right? How that happened.
Well, I mean, JavaScript has a long history, right? I mean, it was conceived at Netscape in the early 90s, and it was put together in a hurry. I don't know if it was 2 or 3 weeks or whatever but we need a scripting language in this browser, to program and so Brendan Eich was given the task of creating a programming language, which he did, and he did a marvelously good job when you consider he only had 2 or 3 weeks to do it.
Right.
And it's our luck that he had been educated in functional programming and Lisp and whatever, and understood like notions of functions as first-class objects and closure over state and whatever, and actually got that right in JavaScript way back when. And that has heavily been leveraged since, right? But then it's interesting. Then through the browser wars, there was like a decade there where Microsoft and Netscape were warring, but JavaScript was never performant enough, and the internet was never mature enough for it actually to be an application platform or programming platform, right? It was like you'd use JavaScript just to, it was more like a glue language, like here, maybe 5 or 10 lines of code just to make this stuff work, right? But don't ever try to actually compute anything in JavaScript. It'll take an afternoon, right? And so that was sort of the established dogma, I would say. But then Google went and did something marvelous. They built the V8 engine and introduced the notion of JIT compilation to JavaScript, and that was actually run by a team of Danes in Aarhus. A guy named Lars Bak was sort of the chief guy on that. They did a fantastic job, and they proved us all wrong that JavaScript actually can be incredibly performant. At the same time, HTML was starting to grow up with H5, and browsers were becoming more secure, and gradually this platform was emerging. This true cross-platform that runs everywhere was starting to come into focus, and of course people were discovering that, and they were starting to write larger and larger JavaScript applications. And it was going well for a while, but then they became really large, these apps, and they had large teams of, hundreds of programmers on them. And then they would discover that they would basically slow to a crawl and at times go backwards because they simply could not scale these large JavaScript apps for a variety of reasons. One being that, there were no classes, there's no object-oriented programming in JavaScript. There was no notion of modules or anything like that. Right, and that was a big problem. But there was also there's no type system, and it's not possible for you in the language to specify what your intent is. You can write the code, and the code will do what it does, but you can't put in place any kind of guides or that say, hey, this is supposed to be a number, not a string.
Right.
Or this is supposed to be an object with the following properties or what have you, right? And that means that it's very hard for you to write code that the next programmer that comes in and maintains it knows what to do with. And it's also very hard for you to verify that these apps are going to work when you run them. And it's hard to build tooling because it turns out that these types are what enable tooling. And that sort of brings me to why it was that we then got interested in TypeScript, because one thing that we saw then inside Microsoft was that teams were coming to us and they were asking us if we could perhaps productize a technology called Script Sharp. We'd heard a little bit of this guy named Nikhil who had written
built WebMatrix, who built the WebMatrix web server and IDE way back in the day, if you remember too.
And we were like, okay, Script Sharp is this thing that allows you to write in C# and then cross-compiles it to JavaScript so you can then run it. We go, well, why would anyone do that? Was sort of our first reaction. We go, well, it turns out the teams were doing it because it gave them access to grown-up tooling. You could write in Visual Studio, you could use modules, you could use classes, you could use interfaces, you could type check your code before you ran it, you could do all sorts of cool things. You got statement completions and safe refactorings and code navigation and all these bennies and you got the ability to document your code by putting types in there that the next developer on the team, would actually understand what your intent was. And we go, wow, well, that's fascinating. So you're actually writing in C#, but you're not running C#. You're treating JavaScript as an IL, basically, right?
Right.
And we're like, but that's nuts. I mean, surely if you want to appeal to JavaScript programmers, wouldn't it be better to try to fix JavaScript? and like make better tooling for JavaScript, or do whatever it is we need to do here to make JavaScript better. And so that was the genesis for TypeScript, right? Was let's do that instead of, because surely you're never going to be best of breed by telling JavaScript programmers that you have to program in another language and then cross-compile to JavaScript. That's only going to get a few percent, right? But if we could make the world better for JavaScript users, boy, that could move the needle.
I have a theory here, which is TypeScript just celebrated 10 years, by the way. So congratulations. I think late October, which is amazing. Makes me feel old because I just remember it like it was yesterday. And I think I would love your theory on why you think TypeScript, if you look at any of the ratings of most used languages, TypeScript is always there in the top 5, top 10, incredibly popular. Why it is so popular. And I have a theory, which is in the 2010 era, Microsoft didn't embrace open source, or if it did, it was very reluctant. What I keep saying but what Microsoft put out on GitHub or how it engaged with the community, they did, but it was a reluctance. But I would say, or anything outside the Windows ecosystem. Now, I think in the last 10 years, and if you look at the success of Visual Studio Code, and if you look at the success of TypeScript, there has been an engagement with the community, which I have a theory, and I would love to, you can tell me if I'm full of shit, which I think has played some role in success. Why do you think TypeScript succeeded? Do you think Microsoft being more open has anything to do with it at all?
Well, I mean, so TypeScript was one of the first open source from the get-go projects at Microsoft. And I would say it was open source more by need than by anything else, because we fully realized that if we're ever going to appeal to the JavaScript community, this has to be open source. Because JavaScript is everywhere, and it's like the platform of that runs everywhere, right? Not just on Windows. And so there's no way we could build a proprietary product here and appeal to the community. I think it was a hard sell at the beginning, back in 2010. But then, of course, there were like changes happened. Like Satya became the CEO of Microsoft. Within a few years after that, and all of a sudden, the mindset very, very much changed at Microsoft. And I think open source sort of has more deeply evolved into some communities than others, right? But the place that it evolved most deeply first was like in development tools, I think. And so already it was evident to us back in 2010 that going forward, you're not going to be able to do development tools if you do not appeal to the open source community. So we're going to have to learn to do open source. We did not know anything about how to do open source. We thought we knew, but we didn't. And in the beginning, with TypeScript, we did what was technically open source, in that we put the source code out there and put a license on it, or a permissive license, so people can have the source code, right?
Right.
But we didn't actually develop it in the open. We still used our internal bug tracking systems, and we would scrape the feedback from, it was on Codeplex. That was Microsoft.
That's right.
Oh my goodness.
Open source repository, which was mostly crickets. But still, we would take the feedback from there, put it into our internal bug tracking system, and then we would occasionally lob a copy of the source code back into Codeplex. But we quickly realized that this is not, this does not in community participation, and community participation is the hallmark of open source, right? And so in 2014, we moved TypeScript to GitHub. And that was really when things began to take off, because now all of a sudden it became possible for the community to actually involve itself in the development of the product. And we've been there ever since now. And our entire workflow is in the open, our design meeting notes, everything. There are no secrets on this project. And it's been liberating. It's been wonderful. And for myself personally, I love that workflow. It is so rewarding to be right there, right next to your users, right? They are literally, they can report bugs in the morning, and you can have a fix in the main branch by afternoon, and people love it. That is like, so it's gratifying for us doing it, and it builds tremendous excitement for the product in the community. So it's just a win-win for everybody. Plus, I mean, even for Microsoft, it invites conversations with groups of programmers that previously we would never reach, right?
Right.
And through projects like TypeScript and Visual Studio Code, now we are bigger in the developer division than we've ever been. In terms of engaged users, right? It's phenomenal.
Like, I grew up in a Microsoft where if you ever posted on any open source program about Microsoft, you would get the $$ soft or a Windows or
$M$FT. Yes, I've seen that. And I think Miguel de Casa said it, but maybe others have said it before. But trust is won in drops and lost in buckets, right? I mean, and it's just, it takes forever to win people's trust. And you got to be really careful, because it takes one dumb mistake and then you're pouring it all out of the bucket again, right? And so we're very, very serious about this journey. And it's been fantastic. I mean, it's been so wonderful to be part of.
Which way, it kind of blows my mind when I see these forums and they say, "Oh, my favorite language is TypeScript, and I'm using VS Code over Emacs versus VI." Right? You'd be amazed how many times when I say an Emacs versus VI debate for the last 30 days, they'd be like, "Well, I don't want to admit it, but I moved to VS Code because it's better than everything else." I really want to ask you this, because I want to kind of focus on Anders, a person too, because one thing that kind of really strikes me about you is there is a risk for architects and designers to become, quote unquote, architecture astronauts, where you are removed. Also, there are certain other maybe people at Microsoft who this might also apply to, but you're so removed from the actual thing that is being built in the way that is being built that over time, slowly, you lose kind of the fine details of what it is that you're designing. And, you have avoided that. You rolled up your sleeves and you got into building TypeScript. I am curious about how you sort of avoid the problems of just kind of being too out of the details and being an astronaut. And then maybe talk to us a little bit about like how you write code and, how you engage with writing, software yourself.
Well, it's interesting because, I've had a long career, right? I mean, it's been 40 plus years of programming at this point. And in the beginning, programming was what I did, right? I mean, and only programming. And then it was only myself. And then I learned, I would say over time at Borland, to become a team player, and then I would say I learned at Microsoft to become an architect and a language designer. And I was gradually sort of moving up towards the stratosphere there, right? I mean, and on C# mostly I would write code, but I would mostly write code on the .NET framework. Like I wrote a bunch of the base classes in .NET and whatever, but I wasn't actually writing the compiler. I was writing the language specification. And there was some unfulfilled part of me there. I did not realize it at the time, right? But I was gradually less and less enthused with that. There was some itch that I wasn't scratching, without really knowing it, right? And it wasn't really until late in the C# project where I sort of felt a bit burned out and took a sabbatical and then whatever, and then discovered that, the thing you've lost your roots, right? You're not actually programming the way you used to, and that's really what makes you happy. And so with TypeScript, when that opportunity presented itself to sort of get interested in this new opportunity, I decided to participate in the coding of it too. And so I wrote the first versions of the compiler. I did not write. That was written by Steve Luco, and then we had a team that tried to, didn't try. They wrote the first the first compiler we shipped, which was written in sort of C# style in JavaScript, and it was not particularly efficient. And I had gotten curious about this other style of programming in JavaScript where you use functional features way more, and closure and whatever. And and I was like, wow, let me try to just write a little parser this way. And now let me try to write a little type checker maybe also, because there was not a whole lot in TypeScript at the time. I discovered that you could write way more succinct code and it ran way faster. And so eventually that became the core of the compiler code base that we're on right now. And I've ended up writing a lot of code, and I still write a lot of code in that code base. I'm sort of the chief committer, I would say, on the type checker, which is the more complicated part of the code base. And it's a lot of fun, and it keeps me happy. It keeps me doing. It makes me also say no to other things. I've never been a people manager. I've never, risen up the ranks. But I also full well know that if I had chosen that path, I would have never been as fulfilled, right? Because this is my calling. My calling is writing code. And so I've doubled down on that.
Okay, so this is a oft-requested question about you. Which is, let us say you want to write a fun piece of code today. Walk us through your tool set, your monitor, your keyboard, what IDE you're going to use. Feel free to piss off half the internet with your choice of IDE, language. What would Anders Hejlsberg use in 2023?
I'm actually a pretty simple guy. I don't have a super multi-monitor, fancy game riggy setup. I like to work on laptops. I always work because it's sort of going all the way back to the beginning of time. And at Borland, I would always work at home several days a week. And that's where I wrote most of the code. And then I'd go in and play ping pong and interact with people and whatever. And I sort of treated work as the place where I wouldn't work. And then I'd go home and work. And that meant I needed the ability to lug my computer with me. And so I had portables back when they were transportables, like Osborns and K-Pros and what have you, with these things that were bigger than sewing machines and weighed a ton. And I would lug them back and forth. And so I've always been on laptops, and I'm still on a laptop. The laptop I have today it's a ThinkPad P1 with a nice 4K monitor or a 4K screen. Nice. A touch screen. It's awesome. I love their keyboards. Once you use their keyboards, you can never go back.
Lenovo makes the best keyboard still.
Yeah.
They still do.
And the OS I use is Windows, just because that's what I grew up on and what I'm very comfortable with. I use Windows Terminal. The new host for the command line.
I love it.
Yeah, and that's awesome. I of course use Visual Studio heavily. My color scheme is Monokai, which I like, and that's kind of it. I used to have an external monitor, but this plugging in and whatever, and it's just get a decent laptop with a big enough screen.
Oh God, so it's the two schools of thought. Like, for example, on the use of IDEs and how you write code. For example, there's a whole class of people who just printf their way to debugging. And then there are others. For example, John Carmack famously falls into this category. John's kind of a legendary Visual Studio user, where you love the debugger, you love being able to put a breakpoint, inspect the state of your program. It sounds like you're in the latter category, but I'm kind of curious about which category. Do you see the appeals of both categories, and do you see yourself as part of the second category?
I'm in both. It sort of depends on what I'm trying to debug. Sometimes I am absolutely guilty of using console.log and just slap it in the middle of the compiler and print out what because the compiler already has internal functions that allow you to convert a type to its string representation, right? Because we need that in error messages. So it's trivial to just have a console.log that prints up what type are you looking at here and here, what are you instantiating now or whatever if you're looking at something generic. So, but then there are also cases where, with type systems and particularly structural generic type systems like the one we have in Typescript, recursion is, you are always staring into the recursive abyss in literally every function where you're trying to relate two types that are deep and they are generative. They keep making new types as you descend into them. It's like there's this parent thing. You can just keep asking for the parent and the parent of the parent and the parent of the parent of the parent. And it never ends, right? And so you build up these enormous call stacks. And at that point, you really need a debugger to sort out, how did I end up here? What's the bottom of my stack look like? And what was it that got me into this cycle? And you can sort of in the call stack see, oh, look, this repeats like 15 function calls deep. It keeps on coming around. And why is this happening? And what do we got to do about it? So I do both. And we do profiling too, or I do profiling too. I mean,
nice.
Because sometimes it's like all of a sudden a compilation takes like, why does it takes 10x longer in this release of the compiler? You got to figure out what is it that's slow here, so now you need a profiler. So there's no one tool that does it all, but console.log or printf, whatever, definitely path of least resistance. It works for a lot of stuff.
We posted on Twitter and said, we're doing this interview. What would you like to ask Anders? And one of the frequently most asked question was around, large language models and AI with Copilot. What is your thinking, or has your philosophy of language design shifted in the light of, the proliferation of AI and how we think about Copilot and everything else?
So there's language design, no. Language design moves very slowly. And we're looking at the 50 years that have gone. You go back 50 years on programming languages that didn't even look all that different than they do now. They're a reflection very much of the machine architecture and the capabilities of the hardware and there are different abstraction levels, and you could envision languages going up the abstraction level and like languages for constructing query prompts for large language models and that sort of thing. But like when it comes to general purpose programming, I don't think it's a much longer window, to answer that question. And we're not in it deep enough yet to know. I do think it's going to change the way we construct tooling. Absolutely. I mean, GitHub, Copilot is one example of that, but there are, oh my God, so many other things that we can apply that to in the tooling, and we're going to definitely, we're looking at that every day, right? I mean, these large language models are at one time mind-blowing in their capability and mind-blowing in their at times stupidity, right? I mean, and it's just, I think I saw a tweet from Tim Sweeney who said, like ChatGPT is kind of like a person with encyclopedic knowledge and the writing skills of an English professor, but with the reasoning abilities of a first grader. Right? And I think in many ways that's true, right? I mean, because these things can cough up the if anyone anywhere has written a piece of code or a piece of prose that sounds like what you're trying to do here, these things can recall and improvise a bit over it, right? But when it comes to reasoning about things, I still think we have a long way to go. And I don't know enough. I mean, I don't think anyone knows where this ends, right? I do think large language models, I mean, when you think about the way we use them currently in products like Copilot or ChatGPT, where you sort of feed a token window of here's like 4,000 preceding tokens or 8,000 or whatever, however big your model is, right? And what's the next token? Well, what's the one that comes after that? And the one after that. And if I reflect over how do I reason about my coding, that's certainly not the way I think of it, right? I don't arrive at my solution to my algorithm by thinking about what the next token is. And so maybe we've discovered that these large language models can do a lot, but we're not helping them reason yet. Because we're artificially constraining the problem by feeding them a bunch of tokens and asking for the next one, and that maybe that only gets you so far. We don't know yet, and we'll see. But I think there's still a lot of undiscovered territory here. When it comes to applying AI to programming.
I sometimes wonder whether it removes some of the romance of building code. For example, when you told us your hash table story, or when you look at maybe legendary piece of code like Carmack's Quicksort, for example, there is a little bit of man bending machine to his will, and there's a little bit of craft to that, which maybe not it doesn't really lend itself like large scale software development. And there's a part of me, as I said, I'm a large LLMs and Copilot, and I see the appeal. There's a part of me which goes like, is some of the romance drained away? Because the next token that's being predicted is kind of the average of all the code written. And maybe in some way that reduces the possibility of somebody coming up with a spark of genius to be like, well, what if I try things this way, as opposed to just tap complete the sort of the median of human output. Do you ever think about that at all?
I do. I sometimes just like joke that maybe we're at the moment of peak truth right now, because what you find on the internet today was actually created by humans largely, right? But from here on out, we're going to be training AI models on a bunch of AI generated garbage that is just regurgitation of their own hallucinations. Right? I mean that's so. Who knows where this all ends? I do think though that AI can help tremendously with a lot of drudgery.
Exactly.
Like going to Stack Overflow and trying to parse through how do I best formulate my answer here, and when these models can just cough up, a great start.
Yeah,
but it
exactly.
does not absolve you from understanding what the code does. And don't think that you can get away with not being a programmer just because you have something like an LLM.
I think you're spot on. I think there's something about using programming knowledge and just people being able to write code to fulfill their kind of bandwidth towards doing something interesting and what they're capable of, as opposed to dealing with drudgery. And I feel like if you're able to deploy AI to just deal with that, to deal with solving, say, tech legacy code, tech debt, that kind of thing, I feel like it just frees up a lot of intellectual bandwidth to focus on exciting, interesting programming problems, which I think is like such a good promise.
I've always said that the thing that I've worked on for 40 years is programmer productivity, right? It's like removing drudgery from programming, like finding your bugs or statement completion, or all of these things. They just they give you more time to do the creative part, right?
Yep.
And I think these AI models can help tremendously with that, because they can just cough up someone already wrote that function, here. Now go modify it to your needs, right? And that's super useful.
Oh yeah, like for example, I think of, I don't know, let's make an example, like let's spin up a VM on Azure, right? Like I can probably spend the next 30 minutes Googling around and finding the right Stack Overflow and sticking the API key or thingamajig, and I know I can do it, but then I know like a million people have done it better than me, and just shift, tab, enter, whatever, that's so much easy. But your point on speak through this, I almost think is profound, because I think of the whole classic ship of Theseus paradox, where you get one piece of this ship, the wooden piece of ship removed every single time reconstructed, and what time can you ever tell when it stops being the original ship and it's actually something new? And I think something there about human generated output and AI driven output. So for example, in 5 years, if most of GitHub's corpus is enhanced by Copilot, and then there is, OpenAI or some company in 2028 training on that, at what time is human input totally removed from what AI is being trained on? There is a ship of Theseus equivalent in there somewhere.
Yeah. It's like that could. You can construct a lot of scary scenarios here. We don't know. We don't know where this all ends. But it is fascinating. When
you think about programming languages today, right? What are some low-hanging problems in not just languages, but in terms of how people write software, that you're like, I would love to spend the next 5-10 years at Microsoft, outside Microsoft or the industry. I would love for either me or the industry to go tackle this in how software is constructed.
Well, I don't think there are any low-hanging problems. If there were, or low-hanging fruit, if there was low-hanging fruit, heck, we would have picked it. I mean, come on. But there are still hard problems in computer science, plenty of them. I don't think, even though I've been in this industry now for 40 years, I don't think we've licked totally the problem of dynamic memory management. We have a bunch of different solutions, reference counting or garbage collection or borrow checkers like in Rust, or all sorts of, but none of them sort of like give you cost-free, safe, dynamic memory management at a systems level, or there's always, you're always trading off something, and maybe that's just sort of the way it is. But it feels to me like we haven't quite licked that one, right? We have not licked the problem of parallelism in programming languages. Far from it, right? How do I parallelize this code? And then when you look at the CPU architectures we're getting today, we're not getting faster cores, we're getting more cores.
Yes.
All the time, right? And so there's a big problem. Declarative programming hasn't really been, I mean, this is what we're talking about, like how do we move the level of abstraction up, right? And I mean, we're making progress in the no code, low code space, but there's still plenty of stuff to do there. I think in some ways, programming languages they're related to the hardware, but they're also very closely related to math. And it's not like math just like changes overnight. This is a slow, gradual evolution and discovery of new things and new constructs and new algorithms and wherever. But I think it's a mistake to believe that there's all of a sudden form a step change. I don't think so. It's not if history is any guide.
I don't know whether you spend time in crypto, but one of the spaces I'm very interested in is the idea of how programming language design has been evolving in the world of crypto. And crypto is a very interesting space for it, because the downside of getting something wrong is not that your program crashes. It's going to be that you lose hundreds of millions of dollars.
Right.
That's right.
And I don't know whether you've spent time with Solidity, but there is a whole ecosystem of programming language design with Move, and there's a bunch of others, which are all about it's actually a very different set of design problems, which is really about safety, knowing exact verifiability, because the downside of getting something wrong is you lose a lot of money very publicly, very, very quickly. And that's another area where I think programming language, they're seeing a lot of interesting design and evolution.
No, there's some interesting problems there, like in static type checking and theorem provers. They absolutely have a lot of applicability in that space. Yeah.
I have a question for you. Maybe a personal question of sorts. One of the things I love about you is you've been in the same company for over 20 years, 25 years now, and essentially been in the same field of programming language design for 40 years. Now, I live in a world in Silicon Valley where people switch jobs every few years, and I've definitely switched jobs, or I definitely switched the kind of job I've been doing. I'm now a venture capitalist. I used to be a product person. And there's just something very deeply romantic about the idea of I'm spending 40 years working on this problem and then being one of the best in the world, if not the best in the world at this. I'm curious just your thought process on that, which is, at any time did you go like, okay, well, I'm done with programming languages, I'm done with Microsoft, I'm going to go off and, build a SaaS spreadsheet software company or something else. Like, just talk to us about what has kept you going in one space for so long.
Yeah, maybe it's just because I'm incredibly boring and risk averse, I mean, but no, I think you don't get to do language design if you want to switch jobs or switch careers every 2 years or 3 years, because it's just like the languages don't work on that time horizon. It's to make a program. I mean, I think in a sense, my career sort of illustrates it, right? Like, every one of the products I worked on kind of took a decade to establish their community and user base and relevance in the world, right? That's the timescales you're dealing with when you're doing programming languages. It's a slow work, like it probably takes a couple of years to bring a programming language like from the get-go to a level of actual usability. And the ante keeps going up because people now expect tooling that is way more intelligent than they used to. It's not enough just to have a compiler with all that goes into that and code generation and whatever, and then type checking and whatever. No. You also have to have language services, and you have to have integration in development tools, and you have to have all sorts of stuff, right? That like big old tool chains. And And it takes a while to get that built. And then, of course, you don't ever get it right in your first release. It's typically not until the third release that a language is truly like gotten it all sort of put in the right place and have all the right features, right? And now you're like 5 years down the line, right, before you even are relevant. So it's a long game, basically. And I like this long game. I like noodling away at it. No, look, we can make it a little bit better here, a little bit better here. And like once we're 5 years down the line, God darn it, it starts to accrue, right? And and that's sort of been the game with TypeScript too, right? We're about to ship version 5.0, but we've shipped more than 40. We've had more than 40 releases of on a typical 3-month cadence through the years there, to get to where we are now. And we are very, very capable as a language now and have a lot of innovations in the type system, but it did not happen overnight. And so I'm the right kind of guy or the right kind of mindset for that sort of problem, right? So that's why
I love it. I think I use the word romantic, and I think it's applicable here, which is something applicable about like doing long-term work and saying this is going to be something, it's going to be important. We're going to spend years at it. And, people write that is code of your, written in C#, running 20 years later. There's code in VB6 still running now. There's probably code older. These are things which last decades, people's lifetimes even. And there's such something beautiful about that, especially when we live in a world where things don't last very long. And I just love that you do that.
No, and I will tell you, it's tremendously gratifying to see and to know that you literally have millions of programmers use stuff that you work on, right? And that appreciate it too. Because programmers tend to be incredibly excited about their tools because they spend like their entire workday in this thing. And when this thing gets better, that's 8 days of better time for me every day, right? So they get very excited, and that's just tremendously motivating and invigorating for those of us who work on these products, right? So
switching gears just a little bit, and this could be a rapid fire round, and maybe a bit spicier. I would love for your quick thoughts on a few programming languages, the good, the bad, anything at all. And I have a few. Let's first start off with Rust. What do you like, not like? What are your thoughts on Rust?
I like the courage to try new strategies for dynamic memory management. I do not like the complexity of the outcome.
This is spicy content. This is going to blow up the internet right here.
Well, no. I think that's fairly well established. That it takes a while to understand how Rust works, right? Yeah. And there are also limitations. Like there are certain typical data structures that become very hard to like a tree with parent pointers. It's like you can't really do that in Rust. Not easily. You have to learn. You have to understand all the tricks to work around the borrow checker to make that work. So okay. But that said, lots of respect. I think, man, that the world was overdue for some progress in systems programming languages, and I think Rust delivers. So yeah.
Well, we're gonna
not moving to this.
I'm gonna make a clip of this and put it at Anders Hejlsberg dunks on Rust and try and make this go viral. Next up, Golang.
I do not like the fact that there were no generics in that language, and it took that long for them to get in there. I think that hampered the language dramatically. I find their approach to interfaces really interesting. This notion that you have there's not as deep of a coupling between code and data, and pointers will carry along with them their own vtables for interface dispatch. So you can sort of marry an interface and a data structure even dynamically and construct a vtable dynamically for that. Where in OOP, that tends to be much more of a fused heavy marriage, and you can't easily construct new implementations of something at runtime. So there's some interesting stuff there.
What do you think about Go's kind of ideas? And because they seem to push the state of the art on concurrent programming models forward, and that may be a reflection of the Google systems programming. You don't seem impressed.
I'm not. They added primitives in the language to start off new threads of execution. But beyond that, it's not clear that issues such as thread safety and all of the other Like I've always said, like if you're programming with, you can have mutability or you can have parallelism, but you can't have both together. No one understands what happens when you have both together, right? I mean, and that's why like functional programming, great, you can do parallelism because there are no side effects, right? Or you can do mutability, but boy, once you add threads to that and free threading and then whatever, oh gosh.
Yeah. And I remember many years ago, I tried to understand Haskell deeply, or actually and OCaml actually. Yeah. And, I tried to understand monads and the whole theory there. And the way I understood it was like, well, side effects are dirty, so wear gloves and touch it very, very carefully, and then tell everybody these things are dirty, and then you pass it around with this big warning sign, with this big radioactive warning sign through the program. Was kind of my mental image of it.
Well, it turns out that this notion of programming with islands of functional purity is actually really a useful way to think about a lot of problems. And so I am actually a fan of, I'm not necessarily a fan of monads and endofunctors and what have you, all this fancy terminology, right? But this notion that you try to park the side effects in a place where you can reason about them, and then you have whole portions of code where you just know, well, there's no mutability over here. So that can just be parallelized, and I will have to think about it because no one ever modifies this data structure, right? So I can have as many threads banging on it as I want, and nothing's going to go wrong. It's empowering.
Yeah. Okay, next one. This is kind of the cool new kid on the block, even though it's a few years old. I don't know whether you spent time with it, Zig.
I looked a little bit at it, but I don't know enough of it about it to offer an educated opinion.
Well, I've spent very little time with it, but I think Zig is sort of a better C in some ways. I don't know whether that sounds blasphemous, but like C fixed, made simpler, easier is how I think about it. Okay, well, last one, Solidity, right? And the whole kind of Ethereum ecosystem programming. Have you ever spent time looking at that?
I looked at it some. I mean, it's, Solidity is not a general purpose programming language. I would call it a domain specific language, right? And I tend to spend less time on domain specific languages. I think it's an interesting problem space. I think whether a whole programming language is merited there is not entirely clear to me, or whether you could have done better with a more sort of declarative form of contracts, and then gradually added the capabilities, that are necessary. I'm not sure.
Yeah, it's actually sort of a religious question, even in the crypto ecosystem. And for example, there are other blockchains which have taken the approach that let's reuse the existing program. Like for example, Solana, which is a competitor to another alternative blockchain. Part of their appeal is that you can use the Rust toolchain and it kind of compiles to this ABI style layer. But the idea is that you get not all of Rust, but enough of Rust, and you can bring the skill set. And I think so. We've definitely seen people take different approaches, but I think you're spot on. Okay, so would love to get a sense, maybe just as you get near the end of this, which is, what are you spending time on now? What are you excited by? What are you spending? What is the week in the next year in the life of Anders Hejlsberg looks like?
Well, I'm continually involved in the TypeScript project. So that my daily workflow is working with the TypeScript team and writing features and fixing bugs in the type checker and in the larger TypeScript code base. Then I also get to consult a lot with other teams at Microsoft, like anything that sort of rhymes with programming language. I have sort of a way of getting involved, and so I've helped other groups with constructing DSLs or like in like language integration or reasoning about whether this makes sense to do or not. And so I try to educate myself about what happens in AI, but it's like drinking from the fire hose, right? And I'm not really a mathematician by trade, so I can only get so far. But those are like some of the things I would say that are in my day.
Would we ever see another programming language that Anders is working on, or is it something that you're thinking about? Is something in the works?
Whenever people ask me that, I say that the world needs another programming language, like it needs another hole in the head. And I already told you it takes 10 years for programming languages to succeed, and I would be like in my 70s by the time such an effort would be relevant, But who knows? I mean, I'd never say never, Nice. The whole TypeScript journey kind of fell in my lap, right? And I wasn't planning it. So maybe, but that's but there are no like.
The other day,
plans.
Well, you mentioned Tim Sweeney. The other day, I saw this tweet/report that Epic is working on a new programming language for the metaverse, right? They have Simon Peyton-Jones.
Simon Peyton-Jones is there now. Yeah.
Who's a kind of a legend in programming design. And it did not occur to me that the metaverse needed a programming language, but here we are, and they have some really interesting ideas. And I again saw a tweet.
Us programming language designers will always like find a way to couple a new programming language to some technology. So we need an AI programming language.
Nice.
Just like we needed an XML programming language. We needed like back when that was the fad, right?
Oh, gotcha. Today somebody was like, hey, maybe for ChatGPT the interface should be a DSL as opposed to the English language, and that's
this seems to work with the. I mean, hey, English.
You never know.
I actually think the natural language interface is the power of ChatGPT. So,
right.
but yeah, prompt engineering is starting to become a bit of a pseudoscience, So maybe there is some need for something there, But too early to tell.
My instinct is the world hasn't seen the last programming language from Anders Hejlsberg yet. And Anders, I just want to say, one.
Such a blast.
This was such a blast, and I just want to say thank you. We told you the story about how I tried to impress her 20 years ago, saying like, "Hey, this whole she hash thing is kind of cool," and but it is the amount of impact you have on the software just impacts every part of our lives. The amount of impact you have on how these things have been constructed is beyond measure. And thank you for everything you've done, and thank you for this amazing conversation. This was so much fun.
We kind of sort of owe our careers, early starts to our careers, at least to you. I think we started at Microsoft. We started working on Visual Studio. I worked on the CLR. But even before that, a lot of our conversations, one of the languages I had picked up very early on was Common Lisp. And, we started trying to think about what would a compiler for Lisp would look like. Then we moved to Scheme. I think Sriram got me a pirated version of SICP.
Yep.
And so a lot of our early conversations were around programming languages and centered around you, for lack of a better word. And so thank you for everything you've done. And thanks for, employing people like us indirectly.
You're welcome. And it's so gratifying to hear you say that. This is like precisely the thing that keeps me doing what I'm doing, right? The excitement for there's nothing more gratifying when you're working on a product to know that people appreciate the work that you do. So I'm really happy to hear that. And thanks so much for having me on this. This was a super fun conversation.
This is super fun.
Yeah.
Thank you so much, Aarthi. This was such a blast. Thank you.
Great.
Thank you.
You're welcome.
Subscribe to the YouTube channel, The Good Time Show by Aarthi and Sriram.